An Illinois State University geologist is at the forefront of the search for rare earths and other materials needed to support modern society. The U.S. has historically relied on other countries for things like rare earths and lithium, but Dave Malone says they are in this country if you know where to look. And that's where he comes in. In this conversation with WGLT's Charlie Schlenker, Malone says there is a rapidly escalating national need.
For all of green technology, from windmills to electric cars, batteries, magnets, things like that require some specialized
speakers,
things.
Screens,
everything.
A whole bunch.
More than you can think about it. And if we want to talk about lithium first, historically, lithium was mined from rocks called pegmatite. So these are associated with granites. So in the Black Hills, we visit as part of field camp. There are old lithium mines that we visit and talk about the lithium occurrence. There's been hard rock lithium mines. There's some that are existing in our country still here and there, but most of the lithium production is overseas. And for that matter, a lot of this other green technology commodities are overseas too. So, we'd call these strategic minerals as well. So that's the federal government sometimes calls these strategic minerals.
So the perception has been that the U.S. doesn't have a lot of this laying around. Is that not correct?
Well, it depends on what grade we're talking about. So if we want to go back to ore deposits 101, first of all, you have to be able to get at something. Is it cheap enough to be able to get at? So it comes down to economy. So if we were paying, for example, copper, there's a lot more $10 a pound copper around than there is $2 copper. Right, so it all depends on what the extraction costs are and what the commodity prices are, whether it's economic to be able to extract. And there's also the environmental concerns, like certain states like Wisconsin prefer not to have any sort of mining whatsoever done. Minnesota, if you have the boundary waters, who'd want to see a copper mine in a place like that? So in places like Nevada or Arizona, where historical mines operate, they still operate. Some of these mines are more than 100 years old, so we're getting lower grade but big volume to make the economics worth. I don't want to get too far off of lithium because lithium's kind of interesting, and I've been sideways involved with this for about 15 years. So the way I first got interested in modern lithium is a lot of times they're doing it as part of brines. So when you drill a water well, we want to drink fresh water, but if you go a little bit deeper and a little bit deeper, the water gets a little bit saltier, and in some of those salts you have dissolved lithium. It kind of goes in with the sodiums and chlorines and seawater. So sometimes your really salty waters that you might find deeper in the ground happen to bear lithium, especially as a byproduct of extracting petroleum. There's a lot of salt water that comes up with that. And historically, that salt water has been pumped back underground just to keep the reservoir pressures up. And people are thinking now, well, we're taking it out of the ground anyway. Can we scour a little bit of lithium out of it along the way to get some commodity from stuff that we wouldn't have thought about previously?
Is that now becoming more cost effective to do?
Yes, it is. The idea is if we're taking the petroleum, if you look at an oil well in southern Illinois, 99% of that's salt water and 1% of it's oil, but they keep it circulating and they can keep that small 1% production going essentially indefinitely. So there's not a lot of oil coming out of the well, so that's the first place we're looking for some of these commodities. Old mine spoil, so places where we mined before that have already been disturbed, can we go in there and look, or is there something that we're already doing that we can maybe take a lithium all along the way?
So is the U.S. going to be able to get an adequate supply of these things given the ramp up in need?
I think that it's going to take some time, but the federal government is really investing heavily in strategic minerals, and the way they're doing that is through grants to the state geological surveys. So there's been millions and millions of dollars put into exploring for strategic minerals, and that's things like your rare earths, your cobalt, or your lithium, the things that we need. And I think this is part of Build Back Better in some way. So some of that $2 trillion investment package that went through Congress a couple years ago is filtering down to exploration. So to get those grants, and I'm kind of affiliated with 2 or 3 of the states and helping do some of the basic research associated with these. Is there going to be enough? Who knows? There's nothing now, and they're working really hard. We're working really hard to find something. So there was one historic rare earth mine. It's on the boundary between California and Nevada that was put out of business because Chinese could do it cheaper, but since it's a strategic issue, they're trying to bring that one back online, and there's another one in the Bear Lodge Mountains, which is part of the Black Hills. It's really close to breaking ground and coming online too. But there's really nothing. So something's going to be better than nothing, but that's a different question. Let's say we can wave our magic wand and make all electric vehicles tomorrow. We would not have anywhere near, we'd only have a fraction of the commodities that we would need to be able to actually do that.
So which states are you involved with?
Well, I work with the Illinois State Geological Survey out of Urbana, and they're looking in several different places. One is the ash from combustion of coal for rare earths. So, there's lots of fly ash pits next to power plants that might happen to be, for whatever reasons, enriched in some of the things that are useful. That's the first place you'd look, right? Stuff that's already disturbed. Some person's trash is another person's treasure. The one I'm more involved with, we're looking at limestones that are rich in phosphorus that were deposited in oceans in Illinois and adjacent states 400 or so million years ago. And the seawater chemistry at the time was able to deposit phosphorus, and phosphorus behaves chemically like some of these things that we're interested in. So if there's phosphorus there as a byproduct, there's these rare earth elements that are associated with it. In Wyoming, I've worked with the Wyoming Geological Survey too. They're looking for rare earths associated with weathering. So, rare earths are only rare because they're not concentrated. You can go to anywhere and do a chemical analysis and find some of them in the ground, but are they concentrated enough? Did Mother Nature help us along the way and concentrate those, make a little bit more?
So how does weathering concentrate?
Well, let's say we have a granite, okay, and we expose the granite to the air. Part of it will oxidize, that's rotting. Anything with iron in it will be able to oxidize. And anything with feldspar in it will turn to clay. So that water reacts with the granite, the oxygen in the atmosphere reacts to granite, and that kind of dissolves away, reacts away some of the things that we're not interested in. So we're able to concentrate through weathering. The minerals that hold the rare earths happen to be really durable in a weathering environment. So they're in the sand that was left behind from that weathering event.
You've mentioned coal ash, you mentioned oil wells, the weathering of granite. It sounds like you really have to be creative about where to look.
Right, you do. And the easiest place to look is where somebody else has found it, right? But then once you run out of things like that, you do have to be creative. And I tell my students that all mineral prospects or energy prospects are originally found in your mind. So you have to think and think how Mother Nature can do these things.
That's ISU Distinguished Professor of Geology Dave Malone. From his research, he says, other people will better know where to look for materials the nation must have to move into a green energy future. Dave Malone spoke with WGLT's Charlie Schlenker.